Assalamu alaikum. Here we have the summative video and experimental and theoretical probability. So in this, let's suppose it's the result of the 20 throw of the dice. Okay. So here you can get the result. They just throw the 20 dice. Okay. And using computer and you will get your answer. Like here is the result of the frequency table. Okay, how many times one will come, that is 6. Okay, how many times 2 come, that is 3. Okay, from here they will just get it from here. How many times 3 will come, that is 6 times. Okay, so these are the, here is the frequency and here is the scores and here is the relative frequency. Relative frequency actually given an experimental probability for each number and theoretical probability for each number based on equally likely outcome, like how many times one will come, so or any digits it will come, so it's 1 by 6, like that. Experimental and theoretical probability are not close. Okay, this is because 20 is small number of throwing. What happen if you have more throw, or the set of throw will be different result. Okay, so the result of the 20, 50, 100 and 200 that are thrown here. Let's suppose we our result look like this one. Okay, from score 1, 2, 3, 4, 5, 6. So it's equal to 20 time and its relative frequency will be 0.3, 0.15, 0.3 as well. Okay, 0 and what we call is 0.2, 0.01 and 1. Okay, so when we add all these numbers, so your answer must be equal to 1. So here the 50 throw, let's suppose this is just for 20 throw, this one is for 50 throw, this one is for 100 throw, this one is for 200 throw. So accordingly you will get your answer. A number of the throw increase, the experimental probability get closer to the theoretical probability. These results are illustrated are the two important results. If you are repeating an experiments, you get a different result, and compare the first 10th row with the second 10th row of these results. If you increase the number of times of an experiment is repeated, you generally get a better estimate of the probability. And 200th row, they give you the better result. Now, a reliable result of the 20th row. Now let's start the first question. The first questions that Alicia has biased coin. Okay, it has been altered on the land of one side more often. She want to find the experimental probability of getting the head. She spin the coin 10 times and she gets 6 head and 4 tail. What is the experimental probability of getting the head piece on these 10 throws? Give your answer in a decimal. So total is head. You want to get the head, so 6 by 10. Okay, so you will get your answer. Okay, that is equal to 0.6. Okay, because we just need to write here 6 by 10 here, that is equal to 0.6. Okay, now explain why this is not a reliable estimate of the probability. She spin the coin another 10 times. This time she got 3 head and 7 tail, because as she already discussed, okay, that she will not it is a biased coin. Okay, so no, sorry, it's not enough throw, so that's why we are not write the answer properly. Okay, so if she did 20 time 30 time like that, so she will get the proper answer. C part, find the experimental probability of getting the head based on the 20 throws so far. She spin the coin another 30 times and she get 9 head and 21 tails. So 9 by 21, that is equal to 30. So what answer you get? You will get your answer that is equal to 3 by 10, 0.3. Okay, so it's a biased. I think he said here a tail would be of an head based on 20 throw. So far, she spin the coin another 30 times and get. Yeah. So this question is linked with the other two questions. Okay. So how it's linked with other two questions? Now here, the first row he was just connected with for the first one. Okay. So this one is 30. This one is 10. Okay, and this one is also 10. So we can add all these numbers like 6 plus 3, that is 9. 9 plus 9, 18. Okay. So 18 and let me check. Let me show you. 18 divided by 50, that is equal to 0.36. That is for D answer. And here 9 divided by 30. 4 5 multiplied by 30. This is 13 multiplied by, yes. Okay, so it will be, so how we will get our answer? So first of all, we need to do 26. Okay, so how we will do this? He say that to find the probability that you are throwing uh, biased on head based on 20 throw so far. Okay, and this one is this she spin the coin another 30 time. Here is for 20 times she already did. Okay, the on a 20 throws so far, and she gets the spin. She spin the coin another 30 times, so total is 50 times. Okay, so 50, if she have 50, so how much, what is the probability that it will be like we call it it will be 30. So what we need to do here, we just add these two number. Okay, so find the probability of getting head based on 20 throw so far. Okay, but she spin the coin another 30 times and get the result that is 9 headed 20 tails. So if we try to do it less, means try to do 20 times, so what answer we will get here? So if we are doing the same thing here, 9 by divided by 20, so you will get your answer. Because she get a 9 head. Okay, so 9 by 20, so you will get your answer that will be equal to 9 by 20, so you will get your answer that is equal to 0.45. Because actually he want us that you must have a head. Okay, that is in 20 throw, but he spin 30 times. Okay, but she want or he want 20 times, so we will divide with the same answer. I am using it, and I am using, actually I'm using a head, and head are less than 20. So I just mention here 9 by 20, so I will get my answer that is 0.45. Now find the experimental probability of getting a head. Always he said head based on all the throws so far. Another 50. Uh, yes, another 50, and 50 time throw gives the 19 heads and 31 tails. Okay, so what we need to do? Experimental probability of getting head. and all the throw. So for the another 50 throw gives 50 heads. Okay, so you just must write here the 19 divided by 50, that is equal to 38, 0.38. Talking with Michal, I was giving him an answer. He said that when I will present, so I was telling him. Okay, now find the experimental probability. All right, guys. I have find an experimental probability of getting the head based on all the throws so far. Of getting head experimental probability. So first thing we need to find the experimental probability. That will be this one. Okay, this one. How to start and this one. Okay. So what we need to do of getting the head based on. So he threw. So let's start it. So here you can see we have six head. Okay, six head here. Okay, and this will have nine head. Okay, 6 plus 9 15. 15 plus 19, that is equal to 34. So we have total 34 head. Okay, so how many total we are throwing? 50 plus 20 7, 70, 70 plus 10 plus 10 80. Okay, so we need to add this one. Okay, so here I write 34 divided by 80, so I will get my answer 0.37. Just give me a minute. Yeah, what we need to write here, we just write here, we add all these numbers. Like here we have 30. Okay, here we have 50. 30 plus 50 80. 80 plus 10, 10 times we spin the count, that is 90. So 34 divided by 90, so we will get your answer, that is equal to 37. 34 divided by 90, so I will get my answer, that is equal to 37, 0.37. Okay, explain why last estimate of the probability of getting cat is most reliable one. Because we will get more chances. Okay, so we will get, you can see here, it is a bias for the largest number of throw. We have a largest number of throw, so just because of this, it's reliable. Now next one, question number. Question number, I think, question number 4. Uh, Aditi make a dice out of the card. She tests it by throwing it sometime. She get the result. Read what Aditi said. Is she correct? Give your answer. The dice is biased because 5 appear much more than the other times. Okay. So 5, we can see 5 9 times. Okay. And the rest of them, that is less than 9 times. Is she correct or not? Question number 4. So question number 4, no, not enough throw to decide it. Okay. Next one, Andrea made a dice that throw it 300 times and he got these results. Andrea is not correct. She could, how could you convince him that the dice may be fair? Because the result is very close. All result is very close. Okay. So just because of this, he mentioned here that no, you should not accept them all exactly the 50. The result of the probability of each code is 0.5. Okay, 0.193, 0.16, like this. If the dice, or if the dice is a fair, theoretically probability is 0.16, and the value seems to be close, and there is no evidence that the dice is biased. Okay, so same like this. Question number 5. Question number 5. A group of the students want to find the experimental probability of getting at the least of the one of the six. So when throwing a six dice, each of them throw a six dice, okay, and two times, and to produce this data, find the probability, experimental probability of the least one six, at least one six students from students A result, Find the experimental probability of the least one sixth of the by the combining result is A, B like this. Okay. First one, we need to find the experimental probability from the one sixth least. At least one sixth of the student of the A result. So that probability will be that is equal to 12 plus 11 plus 15 plus 11 plus 15, 30 and 32 54, 64. This one is 64. So what we need to write here? 64 here. Okay. And how many total we have? 10, 10 and 18, 28, 36. So 36 plus 68, 100. So our probability answer will be 0.64. Okay. So you can see here. This is 0.66. Okay. So next one. Now question number two. Find the experimental probability of each one sixth of by combining the result of E and B. So 12 plus that will be equal to what we call it 11 plus 12, 12 that is equal to 23. So 23 divided by 100. So you will get your answer that is equal to sorry 0.23 divided by 64 because we are talking about only the at least a. Okay, so you will get your answer that is equal to 0.57, same as it is like that ABC. Okay, so you always divide with these number with 64 and here is 23. Okay, so same like this you need to solve the rest of them. Okay, the student repeat the experiment. Okay. Okay, now ABC, it's you are doing the same thing. Okay, so the student repeat the experiment with another 20 throws each time. The combination of the result of each prime weather is shown. Calculate a new estimate for the experimental probability of throwing at least one six. Okay, at least one six means we need to put 70. Okay, at least one six will be 70 and no six will be 30. So accordingly, we will solve this. In fact, the theoretical probability of the score is 0.6 is over to the experimental probability compare with this one. So how we compare with this? First of all, 0.64 because it is based on the all the throw. Okay, and D is 0 0.7 because we will get our answer 0.70 divided by 100. Total we have 100. Estimate based on the 200 throw is the closer. The estimate is based on 100 throw is next closer. Okay. So if it's 100, it's less close, but 200 that is very close. Okay. So I hope you understand this one. So let's come to the next place. That is the end of unit review. End of unit review. It's same as it is. Okay. So there is no difference. You just check it all. And let me show you their answers as well. Here you can see their answers of end of unit review. So you try to do it. If you have any problem, you can ask me in the class, because actually we discuss all this in the class, so I hope it's easy for you to do this. Okay, so thank you, take care, goodbye, have a good day.